Today we are finding the area of regular polygons. So I'm just going to start off with some review. We are going to review how to find missing side lengths of a triangle. On this first one, we have a 30, 60, 90 triangle, so you could use the formulas for that. Or I think most of you are more comfortable with the SOHCAHTOA. So we could find x by using sine. So the sine of 60 degrees equals opposite over hypotenuse. And to solve for x, we would multiply by 15 on both sides. So x would be equal to 15 times the sine of 60. And this gives us approximately 13. On this next one, we kind of have two right triangles in one. We're going to take a look at just one of them to find the value of x. If the whole bottom side is 6, then that means the leg of our triangle, is going to be 3. So on this one, since we have opposite and adjacent, we are going to use tangent. So the tangent of 42 degrees equals opposite over adjacent. Since the x is in the denominator, we are going to multiply by an x on both sides to get it out of the denominator. So x times the tangent of 42 degrees equals 3. And then to get x by itself, we need to divide by the tangent of 42. We'll do that on both sides. So x is equal to 3 divided by the tangent of 42 degrees, which gives us approximately 3.3. So that was just a little review on how to find missing side lengths of a triangle using trig. Now we are going to move on to finding the area of polygons. So first I have a little bit of vocab for you guys. The first word is center. The center of a regular polygon is just the point right in the middle. By the way, just a little reminder, a regular polygon is a polygon where all of the sides are congruent and all of the angles are congruent. We also have radius in our picture. Those are those blue dotted lines. The radius goes from the center to the vertex. And then we have an apothem. The apothem goes from the center to the middle of a side. And notice the apothem is perpendicular to our side. I also want to add something to this picture. I'm going to talk about central angles. Central angles are just the angles that are in the middle, that are formed by the radii. So this is a central angle. And notice this shape has 6 sides and it has 6 central angles. And all of these central angles, notice they form a circle in the middle. And a circle is 360 degrees. So that's the sum of the central angles. To find one central angle, you would take 160 divided by the number of sides. So in this case, the central angle would be 360 divided by 6, which is 60 degrees. So each of the central angles, which are in between the radii, are 60 degrees. So now we are going to see if we can find the area of this regular polygon based on what we already know. So before we look at the formula, first of all, I'm going to draw a radius here and a radius here. So I formed a triangle in this black outline. I can find the area of that triangle. So I know the area of a triangle is 1/2 times base times height. So in this case, the area would be 1/2 times the base, which is 8, times the height, which is 10.1. So this area is 40.4. Now, the question is, how could I use the area of this triangle to find the area of the whole polygon? Well, notice, if we draw all of the radii, we have 6 of those triangles. All right, so we have 6 sides, and we have 6 of those triangles, which each have an area of 40.4. So to find the area of the whole polygon, we could just take our area and multiply by 6. And 40.4 times 6 gives us 242.4. And that would be feet squared. So there's our area of this polygon. Now I want to take a look at the formula for the area of a regular polygon. It says the area of a regular polygon is half the product of the apothem and the perimeter. I want to take a look at how this area formula relates to what we just calculated. Well, the first thing in the area formula is 1/2. If you look up at our calculation of the area, we had a 1/2. The second part is 1/2 times the apothem. So if we look up at our calculation, remember the apothem is 10.1, and we did multiply by 10.1. So we used the apothem, and the area is 1/2 times the apothem times the perimeter. So did we use the perimeter in our calculation? Well, if I were to find the perimeter of this figure, remember perimeter means the sum of the sides, so you find the distance all the way around the figure. And I know each of these sides are 8 feet, and there are 6 sides. So our perimeter is 8 times 6. And if you look at our calculations, we multiplied by 8 and we multiplied by 6. So we actually used this formula. We had the 1/2 times the apothem times the perimeter. We just solved it in a different way. But this is basically where this formula comes from. It comes from the triangles within the polygon. So we're going to use our formula to solve this first example. So in our area, we know it's 1/2 times the apothem, so we'll need the length of the apothem times the perimeter. Our apothem is 12.3. It gives us that. And it gives us one side length of 8. But if we have the side length, and we know this is a regular polygon, we can find the perimeter by taking 8 times the number of sides, which is 10. So our perimeter is 80 inches. So now we have everything we need to solve for the area. So area equals 1/2 times A, and our A is 12.3 times the perimeter, which is 80. So we need 1/2 times 12.3 times 80, which gives us 492. That would be inches squared. Okay. So now we're going to take a look at a regular triangle. So if this is a regular triangle, we know all of these sides are 8 inches because all sides are congruent. And remember, for our area, we need the apothem and the perimeter. Well, I know we can find the perimeter because we know the side lengths. So our perimeter is 8 times 3, which is 24 inches. What we are missing is the apothem. Remember, the apothem is just the line from the center down to the middle of the sides, which is perpendicular to the sides, or a side. And we want to find that length. What I'm going to do is first I'm going to draw a radius here, and I'm going to draw a radius here. If you notice, I just created 2 right triangles. And I'm going to use this right triangle that I just highlighted to find A, our apothem. So I know this side length of my triangle is 4 inches. If the whole length is 8, then the length of this segment has to be 4 because it's half of 8. But I'm still missing a piece of this triangle. With the information we have now, we are not able to solve for A, so we either need another side length or another angle to our highlighted triangle. What we can use is the central angle. Remember, the central angle is 360 divided by the number of sides. So 360 divided by 3, which is 120. So just a reminder, the central angle is like from one vertex to another. So this would be the whole central angle. So if I just wanted to find this angle here, I would divide that by 2. So this angle right here is 60 degrees. And now I can set this up to solve for A. So, since we have the opposite side and the adjacent side, we are going to use tangent. Tangent of 60 degrees equals opposite over adjacent. To get A out of the denominator, we need to multiply by A on both sides. So A times the tangent of 60 degrees equals 4. And then we will divide by tangent of 60 degrees on both sides. So A is equal to 4 divided by tangent of 60 degrees. Now that we have our A and we have our perimeter, we can find our area. Now the reason I am leaving a as 4 divided by tangent of 60 and not putting it in a decimal is because if you round your answer, or if you round in the middle of solving a problem, you're going to have a rounding error. So I'm going to leave a as 4 divided by tangent of 60. And I'm just going to go ahead and solve for the area. So area equals 1/2 times a, which is that 4 divided by tangent of 60, times the perimeter, which is 24. So 1/2 times 4 divided by tangent of 60 times 24 gives us approximately 27.7. And that's approximate. Right, last example. Sorry, I skipped one. Not the last example. Okay, so here we have a regular quadrilateral, which, by the way, this is just a square. And it gives us the radius, which is 6 centimeters. But remember, for our area, we need 1/2 times the apothem times the perimeter. So we need to find the apothem. And we need to somehow find the perimeter. So we're going to use our right triangles to do that. So let's look at this triangle right here that I've outlined in white. We need to find our apothem, and we need to find a side length. So let's find this value down here. And we know the radius is 6 centimeters. All right, to do this, we first need an angle. So let's use our central angle to find the angle of our triangle. Our central angle is going to be 360 divided by the number of sides, which is 4. So our central angle is 90 degrees. Now remember, that's the whole central angle between the two radii. So for the angle of our triangle, we want half of that. So this angle is 45 degrees. Now I want to point out that this is a 45, 45, 90. And we have to find both x and a. But remember, in a 45, 45, 90, that triangle is an isosceles triangle. So those two legs are going to be the same. So if we solve for one, technically we have both of the values. So let's just solve for x. Oops. So if we solve for x, we can use either sine or cosine, because it doesn't matter which angle we use. I'm going to go ahead and use sine. You'll get the same answer either way. If we use sine of 45 degrees, we will have opposite over hypotenuse. Then all we need to do to solve is multiply by 6. So x is equal to 6 sine of 45. And that means a is also 6 sine of 45. So we have our apothem, and we need the perimeter. So remember that x value that we found was half of a side length. So a full side length is going to be 2 times 6 sine of 45. And the perimeter is going to be the side length times 4. So 4 times 2 times 6 sine of 45, which is 4 times 2 is 8, 6 times 8 is 48 sine of 45. So there's our perimeter. So to find our area, we take 1/2 times A times our perimeter. So 1/2 times 6 sine of 45 times 48 sine of 45 is approximately, actually it's exactly 72. There's my color. 72 centimeters squared. Now this is the last example. So we know we're going to need a perimeter and our apothem. Well, it gives us the apothem as 4 square root of 3. So we're just going to take a look at, actually let's look at this right triangle right here. And we want to find a side length. That way we can find the perimeter. So we want to find that bottom length right there of our highlighted triangle. And it gives us the apothem. So I need to find an angle to use to find that value. So we'll use the central angle, which is 360 divided by the number of sides. So 360 divided by 6. Which is 60 degrees. So if the whole central angle is 60 degrees, that means the part of our highlighted triangle is 30 degrees. And notice we have opposite and adjacent. So the opposite and adjacent is tangent. So the tangent of 30 degrees equals opposite over adjacent. To solve for that, we're just going to multiply by 4 square root of 3. So 4 square root of 3 times tangent of 30 is x. And actually, when you type this into a calculator, you are going to get 4. X is exactly 4. So if x is 4, which is half of our side length, we know that our whole side length is going to be 8. So our perimeter is equal to 8 times 6, which is 48. So now we can find our area. Area equals 1/2 times the apothem, which is 4 square root of 3, times the area, which is 48. And this gives us 166.3. And that's all I have.